let's go over this problem. A ball is thrown eastward into the air from the origin. The initial velocity is 50I plus 64k, with speed measured in feet per second. The spin of the ball results in a southward acceleration of 6 feet per square second. So the acceleration vector is a equal to -6j minus 32k. So to understand this problem, let's draw some diagrams. So we have this x-axis and y-axis and the z-axis. Now the ball is thrown eastward into the air from the origin, and so the ball is over here right at the origin. I'm going to throw the eastward. So the way that we define the direction here is this is going to be east and west, and this will be north and this will be south. So it's like this. On the xy plane, this is east, west, and then north and south. The initial velocity is 50I plus 64k. This is the I direction. This is the J direction. This is the K direction. So 50I plus 64k. So it's 50 on the X direction and 64 on the Z direction. This spin of the ball results in a southward acceleration of 6 feet per square second. So the acceleration vector is a equal to -6j minus 32k. So it's -6 along this y direction, but then -32 along the z direction. So the resulting acceleration is going to be pointing this way. Now notice that here it says that the acceleration southward is 6 feet per square second. Yes, indeed, in this direction is 6 feet per square second. However, because remember the gravitational force also on the ball, so it has gravitational acceleration in international unit is 9.8 meter per square second, and it is pointing downward, so it's the opposite of this z direction, is the negative z direction. So that's why we put a negative sign there. This gravitational acceleration in feet and second is going to be -32 feet per square second. So the southward acceleration is 6 feet per square second. And then you also have this downward acceleration to be -32 feet per square second, approximately. What are we looking for? We're looking for where does the ball land. So imagine the ball over here, and it's going to go, because the acceleration is going this way, so it's going to go toward it this way. And we want to know where does it land. Maybe somewhere over here, right? Okay, because the acceleration pointed this way and going down. Okay, let's find out. So to find out where does the ball land, we're going to start with what we are given. We are given this acceleration vector. The acceleration vector is equal to -6j minus 32k. Now, given the acceleration, we can take anti-duality. We can integrate this, and we end with -6tj minus 32tk plus the initial velocity, which we know it is 50I plus 64k. Simplifying, we get 50I minus 60j plus 64 minus 32t k. So that is the velocity vector. Now we can take antiderivative of the velocity vector to get to the position vector. So the position vector RT is going to be, we're going to take antiderivative of each component and then add a constant vector, which is the initial position. But remember, we throw the ball into the air from the origin. So the initial position is actually the 0 vector. So this is going to be 0. Now remember, when the ball landed on the ground, it's going to land on the xy plane. So then the z component of RT is going to be 0. So setting the z component of RT equal to 0, we got 16t times 4 minus t is equal to 0. Now since t is greater than 0, so t will be equal to 4. Once we know the time that the ball hit the ground, then we can substitute this time t into this vector function to find the position of the ball when it landed, which is going to be 50 times 4 I minus 3 times 4 squared j plus 64 times 4 subtract 16 times 4 squared, this quantity k. Simplifying, we're going to get 200 I minus 48 j. Equivalently, this is at the point 200 negative 48 and the z component will be 0. The ball is going to land it over here, this point where along the I component you have 200, along the j component you have negative 48, and the z component will be 0. So you're going to land on this point on the xy plane. The distance from this point to the origin is given by the magnitude of R4, which is the square root of 200 squared plus negative 40x squared plus 0 squared. And that is going to give us approximately 205.7, and the unit here is feet. Remember, we are asked to keep one decimal place. Now we know the distance. We also want to find out this angle between where the ball is landed to this positive x-axis, which is the east direction. Let's call this angle here alpha. So this angle alpha is equal to inward tangent of opposite over adjacent. And we know that it's going to be a negative angle. So how about we just ignore the sign of this? Let's just put 48 over 200, which is about 13.5 degrees. We can conclude that the ball lands about 205.7 feet from the origin and at an angle of about 13.5 degrees from the eastern direction toward the south. The second part of the question we are asked, with what speed does the ball hit the ground? Since we already got the velocity function, now to find the speed when the ball hit the ground, then we just need to find the magnitude of the velocity at the time that the ball hit the ground, which is going to be 4 seconds. Substituting 4 into t, we got the velocity vector is going to be 50I minus 24j minus 64k. The magnitude of this is the square root of 50 squared plus negative 24 squared plus negative 64 squared. That is about 84.5 1.7 feet per second. Remember, we are asked to round it to one decimal place. So that will answer the second part of the question.